Hello students, now we shall apply the potentiometer to find the internal resistance of a cell. To measure the internal resistance using potentiometer. Let consider a cell E of EMF E. Consider cell E, cell of EMF E. The circuit diagram is shown as below. This is the copper strips. This is also copper strip. This is copper strip. This point B. This point A. Here is cell whose positive terminal is connected to point A, and there is a resistance box. This wire is a constant term or manganese. These are copper strips. The length of this wire is 100 centimeter each, and there is a scale also. This point is connected to galvanometer and then to a jockey. This is J jockey. The positive terminal of the battery is connected to point A as well as the positive terminal of the cell of EMF E is connected to common point A. A rheostat, a ammeter, and a key. ये P1, ये P2, this is positive terminal, this is negative terminal, this is rheostat RH, this is negative and this is positive, this is battery. The two edge points of the wire are connected to a battery, a rheostat, ammeter and key K1, then to point B. When in first case, this key is open, only this cell is in the circuit. We put this jockey at different places and we find the potential difference which is equal to the EMF of the cell. That length is, suppose that point is J1 or length is L1. Suppose that is length is L1. In the next time, we insert the key also, K2, and take out any suitable resistance. This is box. Take out any resistance. This is resistance box. Take out any value of the resistance and we again find the null point. The first point was equal to the EMF of the cell, but in second case when the resistance is just in parallel to the EMF of the cell, then there is a potential drop which is less than the EMF of the cell. This way we can find the value of R working. The positive terminals of cell and battery is connected to point A. It is the condition the EMF of the battery should be greater than that of the cell. Now close key K1. And put jockey J at different points. On the wire AB. There is a point at which the EMF of the cell and the potential drop equal to each other. There is a point on the wire the EMF is equal to the potential drop. Between A and J1, let this length is L1. If X is the resistance per unit length, then at 0 point current, zero value of the current, EMF is equal to the potential drop. the potential drop. Then E is equal to VAJ1, that is X L1 into I, or it is KL1, since X I is constant. This is equal to K. Then E is equal to KL1. This is equation first. Now we close key K2. Now we also close key K2. Then a pseudo resistance is taken out. And a suitable resistance. Is kept in the circuit parallel to EMF offset, parallel to cell. Again we take the null point. Again we move jockey at different points to get zero current in the galvanometer. Let this length is, then this jockey is, suppose this is J2 or length is L2. Let the jockey is at position J2 or length L2. Then this potential drop V J2 is equal to X L2 into I. Vj2 is equal to V is equal to K L2. Xi is the constant and L2. This equation is second. From equation first and second, E1 E upon V is equal to L1 upon L2. The resistance, the formula used to get the internal resistance of the cell R equal to E upon V minus 1 into R. R is that value which is taken in the circuit, putting any resistance through this box. From equation, this is equation 3rd, then R equal to L1 upon L2 minus 1 into R, or R equal to L1 minus L2 upon L2 into R. This way we can get the internal resistance of the cell. 1 second. This is our potentiometer. 4 wires each of 100 centimeter length. These wires are either of the constant ton or the magnet. These are the copper strips through which the 4 wires are connected. These strips are conductors. They can allow to pass the current without any resistance. This wire, the end of this wire is A and B. A point is connected to a battery through a resistor and a ammeter and a key cable, and also connected to a cell. The positive terminal of the cell and positive terminal of the battery both are connected to one cable. The negative terminal is connected to a galvanometer and then to a jockey. In parallel of the cell, a resistance box is connected through a key K2. If key K2 is open, then there is no resistance in the circuit. It is just going through the cells only. And the potential drop between the A and J1 gives the EMF of the cell. This is the EMF of the cell. When we throw key K2 and take any resistance in the circuit, then reading differs and the value of L2 is less than the value of L1. In that case, Bj2 is equal to SL2, I is the current passing through the circuit. In that case, SL2 Ix is constant, that is considered K. Then our equation becomes V equal to KL2. E upon B is equal to L1 upon L2, and we put this in equation R equal to E upon B minus 1 into R. Then we get the internal resistance of the cell this way. Okay.